Now, as we have seen parallel adder and parallel subtractor, now we can see that the parallel adder is used to implement the parallel subtractor. Now in the computer system, there are adders are available. There are no subtractors are available. And as I said that the subtraction is performing by the adder itself. Okay. And we have seen the parallel adder block diagram and parallel subtractor block diagram separately. But it is not a feasible solution to use a different hardwares to perform the addition and subtraction by using the single IC, that is a adder. Clear? So what we can do, we can design a circuit, a common circuit which will perform the addition and subtraction operation both. Clear? So instead of implementing the adder and subtractor by using full adder separately into the system, what the system will do? System will have a single circuit which will be able to perform the addition and subtraction both the operations. Clear? Now here in this section we'll see how to perform the addition and subtraction by using the parallel adder subtractor. Now the single circuit is going to perform the two operations. Now to achieve the adder and subtractor by using a single or the common circuit, we have to use the two inputs A, B and the carry input. Clear? Now again we have a seen in subtractor. To perform the subtraction operation, we need the carry input as a 1. Clear? But if you'll observe the parallel adder diagram, then we have used the carry input with the by default value, that is a 0. Clear? But for subtractor, we need to give the carry input C0 as a 1. Because we are going to take the 2's complement of a second number and then we are performing the addition. And to take 2's complement, we are adding 1 from a carry into the 1's complement of the second variable. Clear? So how to achieve the carry input with a 0 and 1? So for that, we can take one common input, that is a mode input, and that mode input will control the operation of the circuit. So when that mode control is equal to 0, the carry input is connected to the mode control. So when the mode control is equal to 0, the carry input will be the 0 and circuit will operate as a adder. When mode control is equal to 1, the circuit is taking the input carry with a 1 and operating as the subtractor. But again we have seen that in a subtraction operation, we have to take the 2's complement, that is a 1's complement of a second variable, that is a B. Clear? Now to achieve the input value of the B, we can use the XOR gate. Because we know that when we are giving the input to the XOR gate as a common input, that is A is equal to 0 and the B is equal to 0. A is equal to 1 and B is equal to 1, the output is a 0. And when the different inputs have a given, then the output generating by the XOR gate is a 1. Now first we'll see the design of the 4-bit adder subtractor, then we'll see how it works. Now let's take, as I'm going to implement 4-bit adder subtractor, I have to use a 4 full adders. So this is my first full adder. This is the second full adder, third full adder and the fourth full adder. The inputs I need to give here as a A0, A1, A2 and A3. This is A0, A1, A2 and A3. The outputs generated are S0, S1, S2 and S3. Along with that, the carry input, carry input, carry input, carry input given as a carry input, and finally it is a carry out. Similarly, this is a carry out, this is a carry out, carry out. Now we are going to use one mode control input, This mode control input is, I am taking here as a M. Now this is a M mode control. Now this mode control input will be either 0 or either 1. It is connected with the carry input. M will be either 0 or M will be either 1. When M is equal to 0, the carry will be 0. The circuit will act as an adder. When M is equal to 1, the carry in is equal to 1 and the circuit is acting as a subtractor. Now the most important input to the adders is the second input. Now the second input is a B0, B1, B2 and B3. But how to give this input? Because to perform the addition, the input should be as it is. And to perform the subtraction in the inversion form. Clear? Now let's say if I am using the M is equal to 0. Now what is expected? When M is equal to 0, the circuit is acting as a adder. Now to act this circuit as an adder, my B input should be as it is. B input should be as it is. Clear? Similarly, when M is equal to 1, B input is, the circuit is acting as a subtractor and B input should be in the inversion form. Clear? Now to achieve B input is as it is and B input in the inversion form, we are going to use the XOR gate. Clear? Now to that XOR gate, we are giving the first input. We are giving the first input as a B and the second input as M. Clear? To the XOR gate, we are giving the first input as a B and second input as M. Now, when I am giving the first input as a B, B may be either a 0 or maybe either 1. And we are performing XOR with the M. Now, when M is equal to 0, B XOR 0, what it will give? It will give me the value B. Because we know that. Suppose if B is equal to 0, 0 XOR 0, I will get a 0. That is, I am getting 0. When B is equal to 1, 1 XOR 0, I am getting the value 1. Means can I say that B XOR 0 is equal to B? I am getting the output B as it is. When M is equal to 0, at that time I am getting the value as it is. And my circuit is acting as a adder. Similarly, when I am taking M is equal to 1, now at that time B XOR M. So B XOR 1. Now B can be 0 or B can be 1. Now 0 XOR 1. What I will get? I will get the value 1. Now if B is equal to 1, 1 XOR 1, I am getting the value as a 0. Means can I say that B XOR 1 is equal to B bar? I am getting a B bar, which is giving me the complement value of a B. Clear? And at that time, my circuit is performing the subtraction operation and it is acting as a subtractor. Why? Because M is equal to 1. Clear? Means by using a XOR operation of a B and M, now we use this circuit as either a adder or either a subtractor. Clear? Now how I can give the B input? Now my B input will be used as a first input to the XOR gate. So first input I am using as a B0 and second input to the XOR gate. Second input is the M. Second input is the M. Clear? Now the output I am giving here. Similarly, the second. For the second full adder, now I am using the XOR gate. Now this is the XOR. The output I am giving, the first input is B1, second input is the M. Similarly, for a third, first input is B2, second input is M. Now I am connecting here. Similarly, For the fourth full adder, the first input is B3 and second input is M. This is M, this is M, this is M, and this is M. Clear? Now this is the 4-bit adder subtractor. Now when M is equal to 0, at that time C will become 0 and the circuit will act as a adder. When M is equal to 0, B0 is whatever the value will be there, M0 is equal to 0. Now B0 XOR M, that is a 0. B0 XOR 0, the B input will be given to the full adder and it will perform the addition. When M is equal to 1, then at that time C in is equal to 1 and the circuit will act as a subtractor. Then M is equal to 1, it is given as a second input to the XOR gate, B0 XOR 1. Now when it is XORing with a 1, then the B is a complemented and it is given as a input to the full adder and full adder is performing the subtraction operation. Clear? Now in this way, by using the XOR gate and by using the mode control input, now we can implement a single circuit acting as a parallel adder and subtractor to perform the addition and subtraction